Hey, talk about frictional force, the two types of coefficients of friction and where they come from. If you've ever pushed something heavy like a tractor or a box across the floor or a car, you know that it's really difficult to get it started moving. But once you've got it moving, you think, boy, let's make sure it doesn't stop, because if we have to get it started again, it's a lot harder to get it started than it is to keep it going. There's two reasons for that. Number one is Newton's second law. It says that, of course, F equals ma is our relationship. It tells me that if I want an object to move, it has to accelerate. If it's sitting there at zero velocity or zero speed, and we want it to move, it has to speed up to something. So we have to apply some kind of a net force to get it to accelerate, which means we have to push harder than friction to get it to start going. Same thing is true with the friction. Once it does start get moving though, the frictional force actually becomes less. So if we were to graph the push on the box or push on the tractor compared to the amount of the frictional force as it's not moving, of course, increases as the push increases. Or if we were pulling a box with a rope or whatnot. Okay? And as we graph this would be the applied force that I'm pushing the tractor with. This would be the frictional force that exists. And I'm pushing and it doesn't move, and both those forces are getting greater until we get to a point here where it finally starts to move. And we've reached the maximum amount of the frictional force that can exist. This would be our F max, for the maximum friction while it's sitting still. And we call that static friction while it's not moving. And we would calculate that force based on the normal force of the tractor, its weight essentially down, how hard the surface is pushing back against it as long as it's on a flat surface. And when it's not on a flat surface, we'll talk about that later, times mu. And what mu is the coefficient of friction. Get rid of that. Our coefficient of friction, and there's two different types. There's a mu-s for static friction, and that's when it's sitting still and not moving, and mu-k for kinetic. Kinetic, of course, being motion, meaning that it is moving. Okay, so here we reach this maximum friction. So the other reason it's difficult to get the tractor started moving, but it's easy to keep it going, is because the frictional force actually becomes less at this point. If we were to continue this graph of force applied and force of friction, we would see that there's a slight decrease. And then it continues out level, where that maximum friction is actually less here than it was before. So we call this kind of, would be our static region. And we call this our kinetic region. One's calculated from the mu, static. And while it's moving, we would calculate this frictional force is equal to the normal force times mu kinetic instead.